Now let's see this. What is the difference between first smallest negative number and the first smallest positive number and the second smallest positive number? So now if you represent this, let's say this is the number line. If it is 0, now if you find out what are all the numbers that we can represent using the representation given, so using the 16 bits. So using the 16 bits, so one is for sign bit you are going to use 1, and then there is going to be exponent and then mantissa. For this one we are going to use 7 bits, and for this one we are going to use 8 bits. Therefore there are totally 16 bits. So how many numbers can you represent using 16 bits? We have only 2 power 16 possibilities, assuming that every number is going to take one representation or one combinations here. In the entire number line we will be able to represent only 2 power 16 numbers, right? Which means we will not be able to represent all the numbers possible, right? Only 2 power 16 numbers can be represented using this. Now if that is the case, then what happens to the other numbers? They will be approximated to the numbers representable. Therefore if you observe it, there will be some numbers which are close to 0 will be represented, and as we grow away from the 0, the numbers represented will be actually getting far. Therefore the numbers which are close to 0, when they are represented, there you might get a little error, less error, but when you go here the error will increase. The reason is, if you have to represent a number which is falling here, either you are going to use this one or going to use this one, right? Now the distance from this point to this point is going to be greater, and as you move away the difference is also going to be very large, right? Here also the same thing is going to happen. The numbers close to 0 will be represented densely, right? And then the numbers which are far from 0, there the distribution is sparse. Therefore if a number has to be represented here, then the error is going to be more. Either you are going to use this one or this one to represent this number, right? So now why is this happening is, you can see this, the difference between the first smallest and the second smallest number here will be very small, and here the difference between the largest positive number and the second largest positive number will be very small. The same thing happens on the other side. From that you can see that the numbers are densely distributed near 0 and sparsely distributed away from 0. Now let's try to find out what is the difference between the first smallest and second smallest number. Now what is this first smallest number? In order to get the smallest number, you have to put the mantissa as all 8 zeros and also the exponent as all 7 zeros. If you are going to do that, then what will be our number? Since it is a positive number, I am going to put zeros. One interesting thing is, even if I put all zeros in implicit representation or in explicit representation, there is no way you can put all zeros anyway in mantissa. There has to be at least 1 1. Now in implicit representation, even if I put all zeros, the number is not going to be 0. Therefore there is no representation for 0 in this whatever till now we have discussed. That is why, coming to when we go to the single precision and double precision number representation, there we are going to see how to represent 0, but here there is no representation for 0. Okay, so even if I put all zeros, the resulting number is not 0. That is what I mean to say. Now what will be the resulting number is minus 1 power s into 1 point m into e power 2 power e minus 64 is going to be the number. Now what is this number? Minus 1 power s means it is going to be 1. Now 1.0, mantissa is 0, into 2 power e. So what is e? E is 0 minus 64, which is nothing but 1.0 into 2 power minus 64 is the smallest positive number that can be represented. Now what is the second smallest positive number that can be represented? In order to get the second smallest positive number, you are supposed to put 1 here, that's it, in the end. So 7 zeros followed by 1 1. So then what will be the number? The second smallest, let's say this is the first smallest. The second smallest is going to be minus 1 power 0 into 1.1 2 3 4 5 6 7 8 into 2 power minus 64. is going to be second smallest number. Why? 0 minus 64 is 2 power minus 64. So this is the second smallest number and this is the first smallest number. Then what is the difference? The difference is this number minus that number, right? So which you will find it out is, if I subtract from this, if I subtract this number, it is going to be 1.1234567 minus 1.0 into 2 power minus 64, right? Now what is that we are going to get? It is going to be 0.1234567, so into 2 power minus 64, right? Now this number is going to be 2 power minus 8, isn't it? So 2 power minus 8, and this number is going to be 2 power minus 64, it is going to be 2 power minus 72. So what does it mean? The difference between the first smallest number and second smallest number is so small. 2 power minus 72 is very small, so 1 by 2 power 72, if you write 2 power, it is going to be, it is closely equal to, you can think of it as 10 power I think 21 or something like that, 10 power 21, close to. So it is going to be 0.0000, so much, right? So numbers which are close to 0, when you represent them, the error while you represent is going to be very small, but coming to the numbers which are far away from 0, the error will be large. In order to find it out, you have to find out what is the highest positive number and what is the second highest positive number. If you try to find it out, you will get the highest positive number as, if you see that, the first highest positive number is, you are supposed to put all ones here and all ones here, right? Then what do you get? So the first highest positive number is going to be 1.1234567 into 2 power, if I put all ones in 7 ones, it is going to be 127 minus 64, which means this number is going to be 63. Alright, and what about the second highest one? 1.11112345667, that is the second highest number, into 2 power 63. Now if I subtract it, if I find out the difference is going to be 0.12345678, if I subtract from this one, if I subtract this, into 2 power 63, right? So this is nothing but 2 power minus 8, so 2 power 63 and 2 power minus 8, it is going to be 2 power 55, right? So what does it mean? The difference between the highest number and the second highest number is very, very huge, 2 power 55. So this itself will tell you that it is densely packed here, and as we go away from 0, it is sparsely distributed. And now once you represent any number between the first number and the second number, the error is going to be very high, right? So that is the meaning of it. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.